So the title is called Reassessing Potency Analysis. And for me, to be honest with you, this is kind of assessing it for the first time. So anyone that knows my background, I've been doing pesticide, chemical contaminants for quite some time. So this was kind of a new adventure for me to actually do UV analysis and do something other than trace level analysis. So I need to thank some people first because I don't want to short that at the end of the presentation. So the four names listed here are my colleagues at Trace Analytics, and we are a cannabis testing facility in Washington State. So these guys pretty much are doing production work most of the time. So I borrow their time when I'm doing method development, and they stay after and help me kind of on their own time. So I have to really appreciate these guys for jumping in and helping me. I also need to thank Agilent and Advanced Materials Technology. So I worked for a chromatography company for about 12 years, so I'm always trying to optimize chromatography. So these folks were kind enough to supply me with some columns to try out as I developed a new method. Okay, so this has already been covered, so I won't spend too much time on it, but generally speaking, what most people are doing for flower and concentrates or extracts. And when I use that term, I'm basically saying something derived from the plant that's just not plant material anymore. I'm not implying any sort of specific type of process. So generally, it's pretty easy. You weigh it, grind it, extract it, dilute it, filter it, and then you put it on the instrument, nice and easy, like that. Where the problem is, and I've been at Trace Analytics for less than a year, so I serviced the industry from a vendor perspective before, but now I'm kind of in a different role. And the problem really is there are inconsistencies. A gentleman today actually asked about it, and it's frustrating for our clients whenever they send out the same material, and we can get into a debate about that, but send out the same material to multiple labs and get different numbers. And so we really do owe it to our clients who are spending money to try to figure out, are we really doing things properly, and what are the reasons for this? So someone's already mentioned the word dry labbing, but I will say it does happen, or there's definitely in this market right now for testing facilities, the product is essentially evaluated on THC content. So that is a lot of times how you get your business. So for instance, we have clients that do all of their R&D samples through us, and then when they go to do their compliance labeling testing, they go to a different lab. And there's a reason for that. So there is a certain portion of the market that occurs, and that's fine. There's nothing we can do about that. But that does not explain everything, all of the inconsistencies that we see, for sure. Another thing I've learned dealing with clients that don't have a scientific background, of course, is that they want a potency number and they want it to 2 decimal places, and they just have never been told, with every method, with any time you test something, there's just a variation. There's a percent error in that value. And so if I say 22% and 21%, that's potentially the exact same number statistically. And so there's a little bit of an education component that we have to continue to work with our clients with. And then what it comes down to is, are the methods that have been developed, it's still a young industry, are they functioning how we think they're functioning? Are they the best they can really be? Anytime a method gets developed and then it gets out and it's being used and over and over by different people, it sees different samples, you learn things. You see where maybe it's not functioning where you intended it, how you intended it to. And that's fine. That's analytical chemistry. So we're still definitely learning And there's also some changes in the market that I think are pretty significant in terms of potency analysis specifically. Sorry, I'm gonna grab a water. So I would say, initially flower, right? People bring flower, plant material in, they bring concentrates in, then edibles were added, and now what we're seeing is what I call formulated products. So this is where people are taking cannabinoids independently, formulating them, taking terpenes, synthetic terpenes, adding them back in synthetically. So it's not, the methods that may have been developed for flower and concentrates may not actually be appropriate for these kinds of new products that we're seeing. So the motivation for this project was multiple. One is, of course, I started at a cannabis testing lab, so less than a year ago, so that was exciting for me to sort of jump into it. And anyone that is an analytical chemist or knows an analytical chemist, I would say a lot of us have a certain type of personality where when you come into a new lab, especially as scientific director, you want to repaint it, right? You think the way you do things is the best. So you come in and you say, yeah, of course, right? So you say, okay, well, yeah, I mean, we have a method, but we could do this better, we could do that better. I like to do it this way. I'm certainly that way. I can't lie. When I started to assess our method, again, a lot of it's coming from chromatography, working for a chromatography company. Our method's 17 minutes. To me, that's unacceptable. That is where we make our money, is potency testing. There's some unique challenges right now in this particular assay because of the way we have to receive our chemical standards. They are limited in concentration. So oftentimes, we are having to do multiple mixes at a single calibration point. In addition, we have a very wide range. And so we're having to do a lot of calibration points. And so just the cal curve itself, if you have a long run, it starts to take potentially half a day or a day. We can't have that. We can't function that way. So speed, obviously, is something that needed to be updated in my mind. So the other motivation, this actually is really funny because in Josh's presentation, you actually had a picture of Amanda on a project that I'm going to talk about, the exact poster. But anyone that knows Amanda Rigdon, we worked together at ResTech for many years, worked on projects, and excellent chemist. And we started discussions, she got into cannabis pretty early while still at ResTech, and certainly since then, about potency and the complexity of the plant and UV analysis, because I'm a mass spec person, so for me to go to UV and have confidence in it, it is a little bit difficult. And so we always sort of looked at that with a little bit of suspicion. Do we really have the selectivity that we need? And Amanda started a project, and I think this was really an important paper, an important presentation presented at the Cannabis Science Conference last year. And she did a project looking at, and this is from her introduction. So potency was the first test brought on, right, for this industry. But there's not a lot of data, a lot of really systematic studies on specificity. So this was one of her, some first work in looking at that. And these are some figures from her poster. And very clearly show that under certain chromatographic conditions, you have interferences. You will have, other compounds that will contribute to that signal that will give you an elevated value. Has every lab assessed this? I don't know. So, of course, chromatography, you can adjust that to try to solve this problem. Even under their optimized conditions, they still saw that there was an issue. So in their conclusions, there were a couple of things. One was, okay, well, we still have potentially some terpenes colluting with our cannabinoids, but in the plant, that's maybe okay for a couple of reasons. One is they're typically at very low levels. So you can make the argument that if I'm looking at a very high level cannabinoid, very low level terpene, the contribution of that terpene to the signal is maybe not significant. Again, we're seeing products coming in and we have clients that are buying synthetic terpenes and adding them into products. So that changes the story now. Also, they concluded that it was assumed that terpenes would not respond well by UV. So one thing we did in this project is we looked at individual terpenes, full spectrum calibration to see, do they respond, where they respond, and try to figure out where are we going to have some problems. And then in order to compare this to something more selective, we just ran a comparison on a method with LC-MS-MS. So the major goals for me, of course, was to try to get something a little bit faster. So conservatively, I'm going to say we have about a 9-minute run now, although I'm not 100% satisfied with the chromatographic method. We currently do 11 cannabinoids. We report out 10. So in other words, there's one that we monitor because we know it can potentially interfere. And we're hoping to at least develop a method for 14. Whether we do that routinely, whether the market supports that or not, we'll find out. The other thing that was one of our goals and something Amanda and I had talked about was, can we actually develop an isocratic method? There's going to be arguments from the crowd, I'm sure, but when you're doing UV where that affects the baseline, it's just easier if the baseline doesn't adjust. Sure, you can background subtract, and you can correct for it, but if you don't have to do it, why do it? So we kept that in mind if we could actually accomplish that. In terms of selectivity, of course, we knew terpenes were already an issue, and so we really wanted to investigate sort of at a fundamental level where and if these are going to be issues. We also went from sort of what I call a fixed wavelength UV to a dyed array detector, which gives you some different capabilities. So for the chromatography, so far we've evaluated 5 stationary phases. We've looked at various mobile phases, methanol, acetonitrile, some different additives, different pHs. We looked at flow rates and column temperature. And the one thing that I haven't evaluated, which I think will actually push us kind of over the edge to a really good method, is the dimensions. So in other words, I got basically a set of columns in standard dimensions to do column screening, and then once I make a determination on the final stationary phase, I'll probably look at a couple of different dimensions. So far this is the chromatography that we have. So this is, I think, actually the same stationary phase that Anthony just talked about. Again, the dimensions are a little bit different. It is isocratic. So really, literally nothing fancy here. You can actually get a baseline resolution if you just back off the organic a little bit, so go about 68, 70. And that will, the problem with that is it adds more time on it, and I'm not into that right now. So you can do this. I think also changing the dimensions should easily get you to baseline. So, for this evaluation, I'm pretty happy with it. So we used our standard certified method for processing the samples, pretty straightforward. So whether it's a concentrate, we just do 0.1 flour, 0.3 grams. We immediately dissolve it in 20 mils of methanol, filter, doing another 1 to 10, and then that will go on LCUV or dyed array. Obviously, MSMS is more sensitive, so we ended up doing an additional 1 to 100, and then in some cases, from that, an additional 1 to 100. And to be honest, some of the samples were still off scale, so it was pretty amazing. But this is what it looks like on LC-MSMS. So this instrument has a Shimatsu front end, a SciX triple quad. This is just the sort of the TIC. This is what the neutral, so that's positive electrospray, negative electrospray for the acidic cannabinoids. This peak here is just the internal standard. So one thing I was hoping for in order to make this comparison worthwhile is once we developed our mass spec MRM method, we ran a fairly high level of terpenes to make sure that they were not going to produce a hit on this method. So when we get a signal from this, it will be from the cannabinoids or something else in the plant that happens to have the same transitions. So good news on that. So the diode array detector, that was a shift for us. It does have some additional capabilities, so multiple wavelengths, you can look at full spectra. So I've been on this instrument about 3 weeks, and so I know it has some additional capabilities where if you do have a co-eluting compound you can do something called a compound suppression. So to me, it reads like a little bit like a background subtraction for a specific compound. So a lot more capability. I'm still learning. Again, I've been doing mass spec for the last 12 years. So the last time I did LC-UV, I'm not kidding you, I was in grad school teaching analytical chemistry, looking at caffeine in drinks, and we had a strip recorder. For the young people in the room, that is where you have a printer, and your chromatogram is being drawn as the sheet is coming out. So for me to sit down at this is super fun. This is my new toy, honestly. So the first thing just to investigate fundamentally is what does the ability to do multiple wavelengths do for us? So really quick, this is our method. 10 parts per million cannabinoids here in the green. Terpenes, so it's about 38 terpenes in purple, and this is at 228, which is where our current method is, that we run on a day-to-day basis. You will see down here that there are some terpenes that are causing an issue. Again, the argument for people that have been aware of this is, but terpenes naturally are very low abundance. The issue is, again, people are adding terpenes back in. So that's not the case anymore. So obviously, these signals are much more disruptive now. So, we started really fundamentally, and part of this was because I had to re-educate myself on UV. So, fortunately with this instrument, we have the ability to do a full spectrum. So this is simply the wavelength. This is the intensity. This is alpha pinene. And you can see, what we tend to focus on are where there's large signal and where there's not signal. So we want to understand those characteristics. If we take a look at all of the terpenes and overlay them, what you'll see is, generally speaking, there's a region where terpenes tend to have signal. And so it's this low nanometer range. Okay, so this is delta 9 THC, and you'll see that the terpene range, of course, is in the area where it has its high signal, but there's other opportunities here for us to actually detect this compound. So just to overlay all of the neutral cannabinoids, you can see there's kind of two general regions, but there's a lot of fine structure in here as well. And so the terpenes sort of, to some degree, eliminate this region from use. We look at CBDA, so an acidic cannabinoid, and it has a much different and more interesting profile. Terpenes overlay, but there's a lot of other areas in the spectrum for us to look for detection wavelengths. We overlay the acidic cannabinoids with the terpenes. Okay, there's still lots of room here for us to look. So I'm going through this with terpenes, with cannabinoids, and I'm thinking, oh my gosh, there's a lot of other compounds in this extract. And really, I just was like, I'm not going to be able to remember all these overlays and what to do. And what if I want to look back and say, wait, does this interfere with this, or what wavelength is this? So I came up with a system. I'm sure it's not anything super inventive, but for me, it's helpful graphically. Pictures are easy. But let's say we take an example here. So this is CBDA, and if I just plot basically a dot, darker, larger to lighter in terms of the maximum wavelength. And I do that for all of my cannabinoids, so basically this axis here is just would be the names of the analytes. So I take the first maximum wavelength and I plot it for each one of my cannabinoids, and that's what it's going to look like. And then I do that from the second maximum, and if it has a third. And there's actually one that has a little fourth down there. So this gives me sort of a landscape or a map of where the potential signal I want to look at. And so I can kind of identify if I say, okay, I want the most sensitivity, my highest intensity. I can basically say, okay, these would be my candidate wavelengths. Okay, so if I do this map and then I also do the exact same thing for the terpenes, so I basically plot all of this information for the terpenes, and I sort of get this map. And this tells me, are there any opportunities where I see signal for my cannabinoids, but I don't see potential interferences? So what I would want to do in this case is look at a certain range and say, okay, wow, this 230 range looks quite nice. What is this compound and where does it elute in my chromatogram? Is it going to cause me any issues? So it makes it, for me, this was easier than trying to look at all of the overlays. So for example, here are we've tested more wavelengths than this, but these are at least 4 that we've looked at. This actually was not, this compound, this terpene, was actually not on my radar before in terms of an interference, but you can see that, if you are looking in this range down here, which I think most people have moved away from this range because you can see the terpenes sit right next to it and will disrupt this signal. But this tells me that maybe this compound, if I am looking in maybe the 210, 215 nanometer range, is something that I need to consider. Also, CBCA sits up here. The first maximum wavelength for a lot of terpenes sit in that area. So what that allows me to do is say, okay, I know chromatographically where CBCA elutes. Let me check this group of terpenes to see where they elute. See if it's going to cause me any issues. So one of the issues actually that Amanda did were these 2 compounds, and you can kind of go back to check. Yes, in terms of their UV spectra, this is going to be a potential issue depending on where you pick your wavelength. So if they co-elute, which unfortunately they do in those systems, this is going to be a problem and something you really need to consider. So once I sort of wrapped my head around that, we decided to look at some samples. So we looked at 26, 17, what I'm calling concentrates, basically non-flower, 9 flower samples, and we do know that some of the concentrates have added terpenes in them. So for calibration, LC dot array, 8 levels, 1 to 500 ppm. This is somewhat analyte specific, so in sample dilution sometimes has to be variable just to get things in the range, because again, you're talking about 0.1% by weight to potentially 100% weight, and so the range is quite wide. Oh, I apologize, that's supposed to be a copy and paste error there. LC, MS, so 8 levels. Essentially, we're going down to ppb range. Again, we're doing all those additional dilutions. And this was even more challenging to try to get samples on scale. The linear dynamic range of MS is not quite as good. So there's quite a bit of playing around that you have to do. So this table is essentially what we found when we compared a few different things. So we report out our results in percent weight. So everything was just back calculated. This first data set is actually our current method that we're running, LCUV, 17 minutes, how we do things today. We looked at 2 different wavelengths here, which makes sense. I think they're very close to what's in the USP monograph. And then we have our LC-MS-MS data here. We have 2 different concentrates. What you'll see is for Del-9 THC, we get actually really good agreement, which is quite nice. And I want you to note that these numbers are in the 20%, so that's what I call for a concentrate a low-ish to moderate level. Here's something very interesting that we saw. So there's a large issue right now with this compound. And you know how I said that we test for 11 currently and we only report 10? This is the compound we know that there's an issue with, that we don't report, we just simply monitor it. So if we move on to 2 different concentrates, the first thing you'll notice is we still have that issue, but we have a different issue. So this is what I would call concentrates that are high THC, and you'll see that there's a little bit of a low bias for MS-MS. I don't know what this is exactly yet. It could be multiple things. It could be the fact that we're legitimately seeing signal added because it's UV. There's other compounds in there that we're unaware of. It can also be, and this is actually my suspicion, that even though we tried to be really diligent about where we were calibrating and the levels we were using for LC-MS-MS, we may have been in a region where it wasn't quite linear, or there was the potential that there was some saturation that we weren't aware of, detector saturation. So I'm not 100% sure exactly what the bias is here, but it's curious that it's happening on the high percent THC, where we had good agreement when the signal was lower. So there's something interesting about that. We also did, I didn't report them here, but we also did do some CBD isolates, so that's something that's supposed to be 100% CBD, and they were, they did test in the 90s, high 90%, and with LC-MS-MS we did see it drop a little bit, so very similar to this Delta-9 THC situation. Okay, for flower, so these are now 2 flower samples. We do actually have pretty good agreement. Again, these are low, but generally speaking, I'm pretty happy with that. THCA, which is what you would expect to see in flower. We have all of the UV-based techniques, and then we have our mass spec data. And this trended with all of the flower samples that we saw, and To be honest with you, I'm not 100% sure exactly. There's some investigation that has to be done. I don't want to say either way at this point because I've not been able to back it out. I've tried a few things to determine if there's an issue. And again, this isn't necessarily a high level, and so there's lots of things that this could be. It could be potentially, is there a matrix issue with the LCMS? Is there an issue with the ionization source being heated that's causing an issue? So there's lots of heads shaking now. So I'm going to get some good information after this, I think. So what this is, I don't know yet. I do plan to do a little bit of investigation. Obviously, this is something we have to sort out because our methods should be able to give us the same number. So I was actually pretty pleased for the majority of the samples and for the majority of the compounds. We actually got very consistent results. I'm quite excited about the diode array and some of the additional capabilities of it that are going to make me feel more comfortable using it because I'm used to doing mass spec. I would like to finalize the chromatography. Certainly that has to happen before we can really settle on detection. I'm going to continue to build my UV landscape. That for me is a really useful tool. I think we're going to run into interferences periodically as we move forward and test more and more samples. And of course, I have to get to the bottom of the discrepancies that we saw in the data. So if anyone has any ideas, I'm happy to take them. So with that, I'm done. Thanks.